Welcome to this explainer. Today, we're diving into literally one of the ultimate cosmic mysteries. Since the very dawn of humanity, we've looked up at the stars and asked, are we alone out there? But, as we've actually started sending probes and rovers out into the dark to, well, try and answer that question, we've slammed into this massive fundamental hurdle. Think about it. How do you find alien life when you literally have no idea what it looks like?
Imagine, just for a second, that you're going on a blind treasure hunt. The catch? You have absolutely no idea what the treasure is actually supposed to look like. You only have a few kind of vague conceptual clues. You know it's highly organized, it's complex, and somebody made it intentionally. And honestly, that is the exact maddening challenge that astrobiologists are facing right now.
Okay, let's dive right into this, because for decades, our search for life beyond Earth has suffered from a pretty major bias. Scientists call it being terrestrial-centric. Basically, that means we strictly look for what we already know. We hunt for liquid water, we search for DNA, or maybe an atmosphere that's just packed with oxygen and methane. But what if alien life doesn't even use DNA? What if it's built on a completely different biochemistry, like, say, using silicon instead of carbon? Or what if its oceans are made of liquid ammonia instead of water? If we only look for the familiar Earth-like markers, we could be staring right at a thriving alien ecosystem and completely miss the whole shebang.
So how do we fix this earthly bias? That brings us to Section 1, the blind treasure hunt.
We need a total paradigm shift. And the solution is what astrobiologists are now calling agnostic biosignatures. These are signs of life that simply don't care about specific molecular frameworks or Earth-based biology. Instead of looking for what life is actually made of, agnostic biosignatures look for what life does to its environment. We have to stop looking for specific chemicals and instead start building an improbability detector.
To build that detector, we move to Section 2, life subverts randomness. Think about the abiotic side of things for a second, non-living, physics, and chemistry. Honestly, the non-living universe is inherently lazy. It always takes the path of least resistance. It tends toward high entropy, simple stability, and these smooth, continuous chemical distributions. But life? Life is the exact opposite. Every single living thing, including you and me, is a localized engine actively fighting against entropy. Life forcibly arranges molecules into highly complex, totally improbable structures just to store energy and information. So to find alien life, we really just need to find the math and the chemistry that breaks the lazy rules of the abiotic universe. Which brings us right to our very first agnostic clue. Section 3, the math of complexity. Now, what's really fascinating here is how we can mathematically prove if something was engineered by biology. Say you find a simple molecule like water or methane out in deep space. Doesn't mean much, right? The lazy physics of nature can whip those up easily by pure random chance. But astrobiologists use something called assembly theory to analyze much more complex molecules. They calculate what's called the assembly index, which is basically the absolute minimum number of steps required to build a molecule from basic subunits. In this process, basic units interact, they systematically link up, and they form these intricate networks through what we call pathway assembly. And 15. This is the magic threshold. Through extensive testing with mass spectrometry, scientists have discovered a hard mathematical limit. Once a molecule's assembly index hits 15 steps, it simply does not form in significant quantities by random chance. No way! A molecule that complex absolutely requires a biological system or some kind of intelligent agent driving the synthesis. So if a space probe flies through, say, the icy plumes of Enceladus and detects highly complex, repeating molecules above this 15-step threshold, it totally doesn't matter if they're proteins or something completely alien to Earth. It is a massive, mathematically proven red flag for life. Our second agnostic clue shifts from math over to chemical distribution. Section 4, the Lego principle.
To really wrap your head around this, think about how life picks its parts. In a dead, abiotic environment, like a lifeless meteorite, chemical distributions are super smooth. You get tons of simple molecules, a handful of larger ones, and a completely equal 50-50 mix of left and right-handed molecule variations. But life isn't smooth. Life is incredibly picky. It acts just like someone building a Lego set. It actively selects specific building blocks because they mechanically fit together. It forces strings of molecules into extremely precise 3D shapes to do very specific jobs. And my absolute favorite part? It exhibits something called homochirality. For example, literally all life on Earth exclusively uses left-handed amino acids and right-handed sugars. It completely ignores the other versions.
So the crucial takeaway here is this.
If we scoop up a soil sample on Mars and find a huge sharp spike in only 3 or 4 very specific complex carbon chains, or we see an overwhelming bias toward just one spatial orientation, that is not random physics. That's a biological choosing mechanism at work. Someone, or something, is actively picking out the right pieces to build a specific machine.
The third agnostic clue relies heavily on physical evidence. Let's look at Section 5, the scars of life.
Remember earlier when we said life is an engine fighting against entropy? Well, engines need fuel, right? And they need to maintain internal balance or homeostasis. To pull that off, cells are constantly actively pumping elements inside their boundaries. They will literally pull in rare elements, things like phosphorus, iron, or copper, and concentrate them at levels thousands of times higher than the surrounding rock or fluid. Dead rocks simply don't do that. Non-living processes distribute elements smoothly based on density. But microorganisms directly mess with mineral surfaces, actively altering the local chemistry. And that leaves microscopic scars. If we look under a microscope and see sharp, sudden boundaries where heavy metals or isotopes drastically jump across a distance of just a few micrometers, that right there is a smoking gun that an active metabolic pump was once operating in that exact spot.
Okay, so how do we actually find this stuff? Let's move to Section 6, Tools for the Unknown. Scientists are currently gearing up for some incredible upcoming missions to ocean worlds like Europa, Titan, and Enceladus. And if you check out the tech they're packing, you'll notice a massive shift. We are moving far away from Earth-specific tools like DNA sequencers and moving toward broad, functional hardware. First up, we've got capillary electrophoresis. This measures electrical charge and molecular size. Its agnostic application? It looks for the Lego principle. It detects unexpected clusters or fixed intervals in molecular weights, which proves molecules were selected on purpose, not just randomly scattered. Then there's the orbit trap mass spectrometer. This beast measures exact molecular mass. It is literally the tool that calculates that crucial molecular assembly index, hunting for that magical 15-step threshold to prove a molecule is just too complex to be abiotic. And finally, fluorescence microscopy. This visualizes molecular binding. Scientists can use completely randomized synthetic polymers to see if anything in an alien sample binds to them tightly. If it does, boom, it proves the presence of precise functional 3D structures. By stepping back from Earth-specific biological manual and instead looking at how life bends the laws of probability, we are finally equipping ourselves to see the unseen. We are no longer hunting for a mirror image of ourselves out there in the cosmos. Instead, we're hunting for improbability. We are searching for those localized little engines fighting the grand decay of the universe. But the ultimate question still remains. Equipped with all these new agnostic tools and mathematical thresholds, when we finally cross paths with truly alien life, will we be wise enough to actually recognize it? Thank you so much for exploring this cosmic mystery with me today.